Have you ever really thought about how your data gets from point A to point B? I mean, it flies across the planet in a heartbeat. But how? And more importantly, how do we know it's the same data when it gets there, that it hasn't been messed with? Well, today we're going to look at two incredible technologies that are changing the game. One uses the light bulb over your head for lightning-fast, secure internet, and the other creates digital records that are basically impossible to forge.
So here's the plan. First up, we're diving into visible light communication. Yeah, literally surfing the web on a beam of light. Then we'll switch gears and talk about distributed ledgers, the tech that makes sure our data is trustworthy. Now, they might sound like totally separate things, right? But one is all about the integrity of the transmission, and the other is about the integrity of the information. You need both for our digital world to really work.
All right, let's kick things off with our first big idea: visible light communication, or VLC for short. You know, our airwaves are getting ridiculously crowded. Wi-Fi, Bluetooth, 5G, you name it. So some really smart people started asking, hey, what if we used a totally different part of the spectrum? What if we could use light? And that simple question is sparking a huge revolution in how we can. So at its core, VLC uses the exact same light we see with our eyes to send data. The absolute magic here is that it can take a regular old LED light bulb and turn it into something like a wireless router. By tweaking the light's intensity at insane speeds, this tech can hit some truly mind-blowing data rates. We're talking labs reporting speeds of 10 gigabits per second. That's a massive leap beyond what you're probably getting from your Wi-Fi right now. Now, turning a light into a data transmitter sounds like something out of a sci-fi movie, but the basic idea behind it is surprisingly simple and honestly really elegant. So let's break down how you actually get a digital signal encoded into a beam of light. The easiest way to think about it is like Morse code on steroids. You take a stream of binary data, your basic ones and zeros, and you feed it to an LED. For a 1, the light flips on. For a 0, it flips off. But this isn't a slow blinking. It's happening millions or even billions of times every single second. It's so fast that our eyes can't see it. We just see a steady, normal light. But a special photodetector on your laptop or phone can read that super fast flickering and translate it right back into data. It's brilliant. And this image right here shows you exactly what a real-world setup could look like. Just imagine, the LED lights in this room aren't just for seeing. They're beaming down a secure, high-speed internet connection. Every light fixture in an office, on a plane, or even in a hospital could become its own data hotspot. In fact, some hospitals are already using VLC because it gives them internet without any radio waves that could interfere with their sensitive medical gear. So the whole system really just boils down to these 4 main parts. You've got the LED light itself, which acts as the transmitter. Then you have a photodetector, which is a super sensitive receiver that can actually see those tiny, high-speed flickers. And then you have the brains of the operation, the driver that modulates the light to encode the signal, and a processor that decodes it all on the other end. Okay, so this brings up the big question. Why use light instead of just sticking with Wi-Fi? Well, the advantages are actually huge. Wi-Fi's radio waves go right through walls, which from a security standpoint is kind of a nightmare. But with VLC, the signal is contained by the walls of a room. If you can't see the light, you can't get on the network. It's just inherently more secure. On top of that, the visible light spectrum is something like 10,000 times larger than the radio spectrum, and it's completely free and unregulated. That means no more fighting your neighbor's router for bandwidth. Okay, so VLC gives us this amazing, faster, more secure pipe to send our data through. But that's only half the battle. Because a secure pipe doesn't mean much if the data inside it can be corrupted or faked. So how do we guarantee the information itself is legit when it arrives? This is where our second big idea comes into play: the distributed ledger. I mean, this is one of the most important questions we face today. When you track a package online or look at your medical records or cast a vote, you're basically just trusting a centralized system run by some company or government. But what if we could build that trust directly into the data itself? This kind of technology could solve massive problems, from making sure the food you buy is authentic, all the way to creating tamper-proof digital IDs. The answer lies in a concept you've probably heard connected to cryptocurrencies, but trust me, its uses go way, way beyond that. We're talking about distributed ledger technology, or DLT, and its incredible power to create trust is built on 3 core pillars. These 3 ideas work together to create a system that's incredibly resilient, transparent, and secure. So those 3 pillars are decentralization, transparency, and immutability. When you weave these 3 things together, you completely change the rules for how we store and verify information. Let's just quickly break down how each one helps build this new system of digital trust. First up, decentralization. It's exactly what it sounds like. There's no central server. Instead of having one single database that a hacker could attack or a company could control, the ledger is copied and shared across a huge network of computers. There's no single point of failure. It's all possible because of clever protocols that let all these different computers agree on what the true record is, without needing a boss to tell them.
Next up, transparency. This is all about creating a shared version of the truth that everyone on the network can see. It's really hard to cheat the system when every transaction is out in the open for everyone to look at. Now, just to be clear, this doesn't mean all your data is public for the world to see. Businesses can use private ledgers where only authorized people can view the data, so you get that transparency but also maintain control.
And finally, this is the one that ties it all together: immutability. Once a transaction is verified by the network and added to the ledger, it is locked in with some serious cryptography. Each chunk of data gets a unique digital fingerprint. If anyone tried to change even a single comment in an old record, that fingerprint would completely change, and the entire network would instantly know something was wrong. The record is essentially set in digital stone. It can't be changed. So, when you take a step back, you see these two incredibly powerful ideas that actually fit together perfectly. On one hand, you have a technology to send data securely at the speed of light, and on the other, you have a way to structure that data so its history is permanent and completely trustworthy. When you combine these two, well, you unlock a future that we're only just starting to wrap our heads around. The real question isn't if this will change our world, but how we're going to choose to build with it.